All right, so we're gonna do a little graphing calculator stuff. This video I'm gonna focus on the stats. So we're gonna do all the stuff with inputting lists. We're gonna go on to the least squares regression line, correlation coefficient, residuals, and regression curves, and then how to clear your memory. So let's go back. Let's start at just inputting lists. So your standard window, we're not going to use too much in stats. We'll use it for your typical thing, but I thought I'd throw that out there. Zoom 6 gives you your standard window, -10 to 10. Okay, so I don't know. Typically we use this when we're graphing lines, not necessarily graphing points. We'll actually use Zoom 9 more often than not in statistics. Um, so back to here, clearing lists. Let's say you go into your calculator, and for some reason, your lists, by the way, are under Stat Edit. So Stat Enter. Here's your lists. If you have a bunch of numbers already in here or from a previous problem or something, just go up to the top and hit Clear, and then come back down or hit Enter, either way, and that'll clear out this whole column. So I'll just do a couple numbers. Oh, Enter, Enter. Let's say you have some numbers in here. And if you have a big list, instead of deleting them one by one, which you could do, in this case, I just hit clear, enter, and the list is gone. So that's convenient to know. Then we're going to input the lists, and then I'm going to show you how to do the checksum. All right. So I'm going to input a list here. The points I'm going to use are this problem from number 91, the shoe size problem that we did in class. So if you want to pause the video, if you happen to have your own calculator, you might want to input all these things here, and I'll do the same. So like magic, I've got my list set up here now. Now I want to check to see that I input these numbers correctly. So if you notice, sometimes in the book, they'll have this little checksum thing down here. That's kind of convenient to have if you have big long lists and you're not sure, you want to make sure that you input the numbers correctly. So if I go, let me get a different pen here. There we go. And I want to focus on this. I want to get that checksum and this checksum. Checksum. This is X and X, and that I put in that list 1 column, and the heights I'm putting as Y's in my list 2 column. And hopefully, if maybe you put that decimal, maybe you forgot the decimal, you wrote 75 instead or something. With big long lists, we have this checksum. So I would go to, one way to do this is to hit stat calculate, and then 2var stats will give you both columns. So I'm just gonna hit 2 and hit done or hit enter. So it says, so it finishes up here. And this summation key is what I'm looking for, this 198.9. So if I go back to that problem, 198.9 is correct. And then if I go down to the Y, summation of the Y column right here, that's 4070, and that was correct. Okay, so we're good there. This stuff, all this other stuff, by the way, we're going to get to in chapter 10 with our standard deviation stuff. Back to this. So we did the checksum. Now let's actually graph them. Okay. So if I just hit graph right now, we have that standard window. It may or may not appear. Probably not if it's set from the beginning, because we need to turn our plots on. If you go to y equals, you'll notice at the top here, these plots are all off. If I go up to one of them, hit enter, and come back down, now it's activated. So the plots would be on now. The plots are settings, I guess you could say. Like this plot 1 is a group of settings. Plot 2 is a separate group of settings. The way you find those is under where you just hit y equals right now, just go second y equals, and it says stat plot. And this is where you can control, like this is list 1 and list 2, which it all defaults to. You'll notice all those. We're going to change this L2 down here in plot 2 later, but right now it's just defaulting to plot 1, so we'll just leave the plot 1 turned on. If I go into it, which I don't have to do right now, but if I go into it, this is what it looks like. I have the on and the off control here. I can change my lists. I can change what they look like. I can even change the type of graph that I'm going to be doing. I could from here go over to plot 2. Let's go up there. Go over to plot 2, hit enter, and now I'm inside the plot 2 parameters here. But again, if we're just turning them on and off quickly, this is where I'm going to probably do it from. All right, I got my plot turned on, so I'm just going to hit graph and see what happens. All right, again, now the points are there, we just can't see them. The quickest way to find them is to hit zoom 9. The calculator is going to automatically find your points for you and make the best screen, like make them fill up the screen pretty much, and there they are. Now, if you needed to find out what the points are and stuff, you could hit trace, and that'll get you. You got to find the cursor right there. That's 6, 153 is that point. If you arrow over, it just jumps to other points. Okay, so that's that. Let's uh, let's make a least square regression line now. So let's do this. We're going to make the line best fit going through our data, and then we'll graph it. So first we have to come up with the equation for it before we can graph it. So let's go back to the calculator. We have all our dots. To come up with the equation, we're going to calculate the equation. So that's under this area here. So stat calculate. And then the number 8 is what we're going to be using more often. We could use 4 for a line of regression, and you could use number 8. I'm not going to scroll down, it's just a slightly different form. This is the typical y equals mx plus b right here. Instead of m, they have a. But in statistics classes and courses and future math classes, we'll be using number 8 more often, that form. So I'm just going to hit 8. And then it's this form. Instead of ax plus b, it's a plus bx. Just meaning that the first number that you see is going to be the y-intercept, and the b is going to be the slope in front of the x. Second. So you have to enter again, and then it'll figure it out for you. So there we go. So we have a plus bx. Our a is 131.2. So that's our intercept. And our b, our slope, is 3.97, if we round that. All right, now notice we don't have any r's here. It's because I had the memory cleared out. I'll get to that in a minute, which is correlation. So we have our line, and now we just want to basically copy and paste it into this spot right here, into our y equals, so it'll graph it for us. And if you want to kind of memorize how you do that, I just think of, like, on a computer, the shortcut for pasting is Control V. And so for me, V means, for me, is vars. So just if you go to vars 5, and then over to equation, and there's a regression equation right on top. So just hit enter right there, and it just copies and pastes it right there. And now when you hit graph, it should have the line going right through it. Pretty cool. All right. Now I want to talk about the correlation. If you go back to that stat calculate, and I hit 8, and I hit enter, I get the line of regression, but I don't have any correlation. That's because it was turned off when I cleared the memory. I need to turn that back on, and that's under diagnostics. So that's catalog. So go second, 0, get catalog. Turn your diagnostics on by going down to D here. Now you can scroll down, but it'll take a long time. The quickest way is just to use your alpha key and jump down to right there, the D's. Now the alpha key is automatically on by default, at least on mine it is. So just hit the X inverse key, which in this case is the letter D. I'll jump you down to the D's, and then scroll down. I think I have to hit it 10 times. I think I hit it 20 times. Nope, I did. Go to diagnostics on, hit enter, and then hit enter again, so it says done. Now the diagnostics are on, so when I go to calculate the regression line, those will pop up. So I'm going to hit 8 here again. Now there's the r and the r squared. So in addition to just that line that was right here, we have the r squared. Now in class we talk about the r and the r squared more, but this regression, we want this, if it's a good line, like if this data is good data to fit a line to, this correlation will be high. So this is called the correlation coefficient. That's the r. 0.86 is pretty high. You want it to be as close to 1 as possible. So 0.9s are better. 0.8s are pretty good. When you get down to the 0.6s, 0.5s, and lower, down towards 0, then it's not a very good fit. Like, these points might be totally random. And if they're totally random, you'll get 0 for r. If, by the way, the line's going down to the right, then this r will be negative. So it just means that there's a negative slope. It doesn't mean the slope is 0.86. It just means that this is a positive slope in this case. If it were negative, it would be going down to the right. R squared is it can be applied to the real world. It can be changed to a percentage, and I want you to understand in class, when I ask this question on the test, to interpret this R squared to the situation. You'd say something like 74% of the variability, use that word variability, in whatever this problem is this human height, so in the y, so the variability in the y column basically can be explained by a linear relationship with the X, in this case, the shoe size. It doesn't mean it's caused. It doesn't mean if you have bigger feet, it causes you to be taller. It just means there's some association. Okay, there's some relationship between the two. Okay, and the higher that R squared is, the stronger the relationship this is. Okay, let's go on to, I had correlation. I got that. Residuals. Uh, there are a couple ways to do residuals that I found, one more convenient than the other, but one way, I'd just go to your list. So edit your list, and I could make this third column my residual list. Like if I want to find the distances between these dots and this line, those are residuals. And if they're below, it's going to be like negative distance, I guess you could say it that way, but it's negative numbers down here and how far they are vertically to the line. Those are residuals. I could have L3 figure that out for me. So I'll do that just so you have it. So you have those values. So I'll go up to L3 so it does the whole column at once. You don't have to do them individually. And then you're going to go to the list, which is second stat. And then number 7 is resids. So residuals are right there. So there's my residuals. As soon as I hit enter, it's going to apply that to this whole column. So there they are. And the negatives are below the line and the positives are above. The bigger the number, the further away those dots are from the line best fit that we're estimating to go through the middle. Okay. Now, if I want to graph this residual, because I'm going to ask you to graph the residual plot, you're going to have to, in this case, you'd have to change your plots and maybe go to plot 2 and then change this L2 so it graphs the X list to the residual list, which is actually L3 in this case. Now, I'm going to prefer to do this a different way. I'm going to go down to this and just change it so this is the residual list right here. It just says resid. So let's do that the same way. So go into your plot 2, go to your Y list here, and just type in resid like we did a second ago by doing the list. So second stat 7, and then notice now the resid is right here. So you don't even need that third list. Like if I go to stat edit, I can delete that whole, oops, go back up there. Clear that whole list out of there. Don't even need it because I have my residuals in my stat, in my, right here, in my second plot. Okay, now right now it's turned off. So this graph I have here is going to be, because that's turned on, that's just my regular scatter plot. So I'm going to leave this set up, and I would suggest you do the same thing if you have more than one set of residual plots to do. I would just leave this set up this way. So you can just turn plot 1 on for scatter plot, turn it off, and turn plot 2 on for your residual plot. And we're going to get a lot of practice doing this in a few minutes. So let's go ahead and do that for the first one. So let's turn this off. I'm going to actually go this way. I think it's quicker to go up there, turn that off by just hitting enter. Go over to plot 2, hit enter, that turns that on. We don't need this line anymore, because I just want the plot. Now when I graph a residual plot, it looks a little different than the scatter plot. I'll just hit graph, I'll show you what I mean. Now nothing's going to show up here until I hit zoom 9, and then it finds it on the screen. Now this is the same set of data that we just had with the diagonal scatter plot line, but these are all the residuals. These are the distances above and below the X right here. Okay, so it's X comma residual distance, X comma residual. We want this residual to be scattered. That's very important to understand that. If this shows a pattern like a curve or something, then that means there might be a better line best fit or a curve best fit that would fit the set of data. Okay, but this is pretty random, so this is a pretty good line. So it's a good set of data to have a line go through it versus a curve. So on that note, let's talk about regression curves. So I want to go to this page, regression curves, comparing the residuals, compared to like a residual line versus a residual curve, those plots, and see which one's better. Okay, so go back to our calculator. I think I'm going to go to a different problem. Oops, wrong one. Let's go to, let's go to this problem. This is number 105 in your book. And we already did this in class, but I thought this is a good example to show this. So if you happen to have your calculator, you can input this data. Just replace list 1 and list 2 with it. And when you do that, I'll get started here to show you. Make sure I would just go to the list, stat, edit, so you're on this list. Go up to L1 and hit clear again. Hit enter. Go up and over to, or over and up to L2, clear, enter. So they're cleared out of there. and then go ahead and start inputting the lists. And like magic, my list is right there. I'm going to clear this off. So I've got my list in there. Hopefully you have yours in there also. I'm not going to read this problem at the second. You could read this on your own. We'll come back to kind of the particulars of it in a little bit. But let's go ahead and just make our typical line, our regression stuff. So I'm going to graph this. I've got them on my lists. So if I just hit graph, okay, we'll see what happens. Nothing's going on here. Now, stuff like this is going to happen all the time to you. So for some reason, you get some errors popping up. You're like, I don't know what's going on. It says dimension mismatch. If I go to my list, it's probably not going to be that. Oh, I got to hit quit. Go to stat edit. Go down to the bottom and make sure your lists are the same. And they're the same length, so that doesn't seem to be it. More likely, it's that your plots are on or off. That shouldn't be. So up here, this plot, let's clear that out of there. So let's just go up to a regular plot, enter, and see if that's it. And if it's not, we'll figure something else out. There we are. So I graphed that and it's working. I just have to hit zoom 9. There we are. So there's our set of data. Now it kind of looks like it's curving, doesn't it? Kind of like a parabola. So that's kind of a hint. But you can still draw a line through it and see if a line still fits the data. Okay, so we'll do that. So hit calculate first. We have to calculate the regression line, and then we can graph it. So go over to stat, calculate, number 8, if you remember. Get a lot of practice at this. Enter. There's our line. So it's y equals negative 19.9 plus 1.95x. And we want to copy and paste that. So I'm going to go to my y equals. I'm going to paste it right here, which is Velcro, or Velcro. I just remember V for Velcro. So Control V on your computer, which is vars. And then 5. Over to equation. Plug in the regression. So hit enter for there. Now there it is. Now if I hit graph on that one, it puts the line right through the middle, which is what I want. All right, pretty cool. Now if I go to the residuals, that's going to tell us more about if this is a good line. Hopefully this is random points around the line. So if I go to my y equals, I turn my plot 2 on now. Oops, got to go up. I'm turning 1 off and 2 on. I'm actually going to delete this out of there, this equation. If I hit graph now, I don't see randomness here. Now I still want to go to zoom 9. It'll make this more pronounced to make a better screen for me. There it is. Now you can see it's very obvious that this is more like, looks like a parabola. It looks quadratic. They're definitely not randomly put on this residual plot. So in this residual plot, you're looking for no patterns. If I have a pattern, there might be a better fit. So let's look for that. So let's go to calculate again. So stat, calculate. And instead of number 8, which is linear, we can go to number 5 for quadratic. Or we could go down to number 10, which I think in here is like a 0. I'll scroll down even though this is pretty slow. Exponential. And so we're going to kind of focus in our class on the 2, quadratic and exponential, and then plus the linear, those 3. I'm going to do 5 because it looks like it's more quadratic. Plus, if you look at the actual problem, oops, that's not the one I wanted. If you look at the problem, it talks about circular lids, diameter, area of the stuff, okay? And that's area equals pi r squared. So this has to do with squares. So it has to do with quadratics. So that's what we're going to do. We're going to use that. So that's how, you look at the context of the problem. It gives you a better hint on which one to try, if it's going to be exponential or quadratic. And then you need to understand what all this stuff means. Y equals ax squared plus bx plus c is the same as, like all these values, a, b, and c can be plugged in for those letters. So if I say, what is the equation? You have to write y equals 0.039x squared plus negative 0.002, maybe if you round it, x plus 0.035, let's say. Okay. Now it gives us an r squared, like correlation coefficient squared. It's handy to know this, and it has some relevance, but just so you know, it's not figured out the same way as the linear one. So you can't compare this r squared to a linear r squared. So just kind of keep that in the back of your mind. Now let's graph this. Okay, so if I go, I'm going to turn my plot back to plot 1. So I'll go up to the top, hit enter. Okay, I've got those dots in there. I'm going to graph them. Okay, can't see it, so zoom 9. There's the curve. I want to graph the line or the curve that goes through there. Before we had a line going straight through. Now hopefully the curve that we came up with will go right through there better. So go to y equals and paste our regression curve that we just figured out a second ago. Put that in here. So I'm going to go paste as like the v, so vars 5 over to equation, enter. And then now for me, I have to put this little power of 2 here for whatever reason. You shouldn't have to on your calculator. And then if I just hit graph, it'll fit right through there. Pretty cool. That fits a lot better than the other one. Now, if you want to see to prove that it fits, we go to our residual plot. So I'm going to go back up to here. I'm going to clear this out. I don't need the line anymore, the curve. Turn off plot 1 because I have plot 2 as my residual plot. If I'll remind you to go to second y equals. Right here it says L1 resid. So my plot 2 is set for residuals. Very important you do that ahead of time. Now when I graph that, all these residuals are real close to the curve, which makes sense because the curve went right through the dots. So if I get a better view of it, so it zooms in pretty tight, so zoom 9, we can see that these dots, so they're not right on it, but they're very close to it. Now, this is better. This is more random. You don't see a pattern of a curve or anything. These are just random points about this line, this curve. If you want to see how close we really are, you can hit trace again, and you can see like this point right here is 10 comma negative 0.04. So it's 4/100ths away from that line. We're really zoomed in tight. So these are real close to the line. Go to the next one, you can see how close these are. This is 12 comma 0.03. Get the idea? I'd like to do one more problem. Let's go to this regression thing here. Number 107 in your book has a little different variation of what's going on here. It just gives you extra practice on doing these. So go ahead and input these numbers if you have a calculator. Put these numbers in your calculator. I'll do the same. So when I go over here, I just input these values. So I have my list. If for some reason you're having trouble doing this, don't forget, go up to list 1, hit clear, and then enter or arrow down, and that'll clear out the list. And then you can input the values. Now when I have these and I just want to do a regular scatter plot, I have to turn my plot 1 on, my plot 2 off. So for me, it's just quicker to do it up here. Hit enter each time. Okay, now when I hit graph, don't see it. Okay, so I need to do zoom 9. Give me a good screen for it. There it is. Now, I can't really tell if this is linear or curved. It looks like it's kind of curved, but I'll do a line of regression just for practice here. So stat, calculate the regression line first. That's 8. And then I'm going to hit enter. And then there's other information. I'm going to paste that stuff. So if I go y equals, hit my v for vars. So v5, vars 5. Go over to equation, enter. Oh, there it is. Now if I hit graph, that line should go through there. And again, you can check your residual plot. Now I'm guessing we'll still see some kind of a pattern. So if I go to, okay, so if I want to graph my residual plot, I'm going to go to y equals, clear that out of there, turn my plot off, and turn my other plot on, which is my residual plot. I'm going to hit graph. It's not there. Zoom 9. There it is. Now there's a definite pattern. It's not totally random. I see kind of looks like a V, but like a U shape. Okay, it could be a parabola, could be exponential. So you got to kind of go back to the situation. So let's look at the problem. Dry ice evaporates. Now this has to do with, we talked about this in class, exponential growth and exponential decay. With evaporating, we talked about half-life a little bit, and when you real roughly, if you start somewhere, you cut it in half after one, cut it in half, cut it in half, cut it in half. Each time you get lower and lower. This is exponential decay. Okay, so this is the situation. This has the form of a times b to the power of x. They can change these letters, but we did this with sequences also. So if I go to my calculator again and I go back to calculate, so stat edit, I'm sorry, stat calculate. And instead of going to 8 or even 5 for quadratic regression, let's go down to the 0, which is that exponential regression. And then hit enter. And let's use this line and see if that's a better residual. Okay, so if I go y equals, put it in here, so vars 5, over to equation, put that regression equation in there, and graph that. Now right now I'm on residual plots, so I need to put my X here. You won't have to do that, I don't think. I'm gonna go back up to the top, turn this on, turn that one off, and hit graph and zoom 9. I'm kind of rushing here because kids are waiting for me with smiles on their faces. Oh, it's still graphing here. Now that it's done, now I can hit zoom 9. And now it's got a nice curve going through these dots. I didn't want to make a line through there. The line wasn't the best one. I can double check that with the regression line. So last thing I'll do here is go back up to my plots, clear that out, turn off that plot, and check the regression for that one. So that plot 2 is on now. I'll come down to show you. Now when I hit graph, it'll go quicker when you don't have the line. So I can hit zoom 9 right away. And now that's much more random. So this is going to be a good, so that curve must be a good curve going through these dots versus the line, which showed a pattern. You don't want to see the pattern. And then the last thing, and then I'm finished, is clearing your memory. So quickly, if you want to clear everything, simply go to second plus, go down to 7 for reset, over to all, to the right, and then hit 1 or enter, and then 2, and that'll reset everything. And then life is good, and this video is finally done.